We just did a direct exposure of a tobacco leaf, and if we go to our database and look up, this is a list of things that show up in tobacco. So this is actually burned tobacco. There's some nicotine and a couple of other related compounds. So if we search this is a positive ion spectrum. So there's nicotine directly in our tobacco leaf. But if we zoom in on this, you can see that we have more than just one peak, and these are all from our nicotine. These are the isotope peaks. So this is a high resolution mass spectrometer, and the formula for nicotine is this C10H14N2. So if we take that, we can do an isotope calculation that tells us what we expect to see. So we should expect to see the base peak for nicotine would be at 163.123, and we would expect to see another peak at about 164 that is about 12% of that peak, and then another one that's about 1% of the big peak, and then another tiny peak that's only 0.02% of this major peak. So if we go back to our spectrum, what we see is nicotine at 163, the first isotope peak at 164, that's about 10% of that peak. Then we see another peak that's about 1%, just a tiny little blip at 165. And then somewhere out in here at 166, we should expect to see another very tiny peak, but it's sort of lost in the noise here, so I'm not sure we can identify that. But these are the isotope peaks based on carbon 12 and 13, hydrogen and deuterium, the different isotopes of nitrogen.